Hi everyone, and thank you so much for the time, and I hope everyone is enjoying the wine. I'm even more hopeful to give you something here worth remembering as well. It's going to be a really quick 20 minutes or so of content, so we won't go into very much depth, but I did want to give you a sense of how we see the shift into more dynamic cloud environments as a major challenge in how we address security, certainly, but even more so our defense posture. Defense posture, as I'll use it here, is how we think holistically about shrinking the windows for attackers across the IT spectrum. We often think of encryption and certs, user access kinds of things, but many breaches are caused by things like misconfigured infrastructure, accidents in our manual processes, things like that. So to start, let's examine how our attack surface is really expanding rapidly, and then we'll discuss how we can mitigate that exposure by applying new principles and approaches. So to help us look at how the attack surface is expanding, let's start with an application. Generally, we're pretty solid at locking that down, right? So here we have the app, and then we'll use a little OAuth or a simple auth method for getting access, right? Log in before handling sort of thing. If that was the scope of what we were looking at in terms of exposure, that'd be pretty simple, but we have demands to get access to external data sources, as an example. And generally speaking, I need a user ID and password to get access to this system, and that is going to be embedded in my source code, some form or fashion. Now, this introduces some new openings because applications tend to be fairly chatty. Right? So I am going to log how this application is behaving. And in that log, I'll see that a database call was made and what the credentials were used to get access to that database. Now, I'm probably also going to want to have some form of performance management solution. So my APM is also going to tell me, hey, here's how performance looked on this application at this time, and it was a database call. Here were the credentials that were asserted and the time associated. And then I also have things like source control, obviously. And when I'm looking at my version control system, I'll have multiple copies of these passwords, especially if I was hosting them in the clear. And generally, a lot of our applications started here because we felt like we were in a very trusted environment. And we ended up with very long-lived credentials from the database because nobody wants to be around when that credential expires. So the DBAs would typically, give me some sort of really long time to live on that user ID and password because they want to be out of the office by the time it expires. But that application lives inside of an environment, and that environment is going to be a server, and that server is going to be virtual or physical. And there's going to be a number of things on the server that add to kind of that attack surface, different ways that I can get access to a host system that potentially can get me access to the application and or additional networked resources like the database. And so I end up having to be very careful with the way that I handle things like the operating system, various frameworks, Ruby, Java framework, Spring, all of that type of stuff. My shell and scripting environments are great places to run hosted processes, and then various other hundreds to thousands of processes that are running in the background for full-fledged OSs. And naturally, we look to lock those down by keeping the server quite static, stacking on some antivirus and then maybe some anti-malware solutions that basically are trying to scrub the environment for unwanted malicious code and prevent attacks that we're expecting to come in. And those types of environment exposure, let me reshape that, are going to be replicated across many of the assets that are running for us in the cloud. So, and when I say cloud, by the way, I could mean on-prem or off. I'm not specifically saying this isn't in your private data center. Originally, we're talking private data center, but cloud is going to exacerbate this situation. So everything that we're running is running in some form of hosted environment, and that hosted environment has all of these potential exposures. And then we get even more intricate as we start moving into things like microservices architectures, where the application is not a single binary running out there. It's dozens, potentially dozens or hundreds of individual services that have to communicate with each other, all with their own hosted environments. Maybe a number of them are hosted on individual environments or clustered. And then I have to start thinking about how I identify those services and encrypt the traffic there, so that, knowing that there's a higher risk of penetration now because the attack surface is so big, I'm going to start implementing things like PKI for mutual TLS. So as you can see, as things kind of explode out and the attack surface for this one application is quite extreme, maybe we can talk about simplifying access to this application by having a hardened network perimeter. And so the idea is I want to close all the doors around this and create kind of a high trust environment for the application to work in. And so I'm going to have what I'm looking for is a very hardened perimeter, and then I'm going to have a small entry point that all traffic has to come through, and I'm going to defend it a number of different ways. Web application framework, SIEM, load balancer, firewall. I'm going to stack a bunch of technologies, maybe even, an API gateway. Maybe I'll put that in there for monetization or some form of additional management on top of it. But the point is I'm going to really kind of buffer the systems inside by preventing access holistically to the environment and hopefully helping to shrink my attack surface. Now, additionally, if I'm not 100% convinced that gateway is going to prevent access, I'll go ahead and segment the network and add additional firewalls, load balancers, between different departments, applications, service classifications, data stores, etc. And I'll use those VLANs as a way to kind of divide things out and do a lot of indirection, requiring a lot more passwords, things like that. But then we start adding trusted connections to things like public clouds and our SaaS providers. And as we continue to move further into the multi-cloud world, we're just adding more of these, right? Amazon, Azure, Google, Alibaba, if we're operating in Asia as an example. And all of these are making our network a little less easy to define. So basically what we're looking at here is we're assuming in the first scenario, before we introduce cloud, that we have attackers that are outside and we're denying them access because we have limited the attack surface to that single ingress point. But now I have lots of ingress points. And so if I'm uncertain as to the network perimeter's resiliency to repel attackers at 100%, I have to start considering that it's possible that I've got an attacker on network somewhere in my federated data center sort of situation. And if that attacker is in the cloud, it's quite possible that through trusted connectivity, they can emulate some form of traffic and be on my network. And then we add even more exposure when we start putting our enterprise functionality into those public cloud providers, SaaS providers, etc., customer data, things that are very important, sensitive to us as a firm. And now I have to trust a lot of additional network that's very difficult for me to define and lock down. Other things that we start thinking about are things like, what about these kind of like shared credentials? So if I'm trying to deal with something like a breach, it's very difficult for me to find where the breach came from if I'm not really good at issuing and revoking user IDs and passwords in some sort of automated fashion. Am I dealing with Sev1 expirations, which are causing failures in the data center? And then I guess the last thing that I'll mention is at what scale can my processes keep up? So if I am going through ticketed processes to issue passwords, to request networking holes, all of that kind of stuff, that worked when we had a few releases a quarter. It's much more difficult to drive efficiency when we're doing it 100 times a day. So that's kind of one area of how our attack surface has really grown over time. Another way is that we have a ton of manual processes. And manual processes, if you've seen presentations from us before, you've probably seen some representation of this. But the idea is that I have numerous siloed teams focused on individual pieces of technology. These technology experts are the ones who will receive the ticket and do something with it in order to provide service for the development teams. So developer will file a ticket against the VMware team for compute, and then the F5 team for load balancing, and then a firewalling team, and then public cloud team if we're asking for a VPC or something like that needs to be standardized. So the challenge is here, there's a lot of manual configuration that often can be very difficult for us to track and deal with. So we have an introduction of risk. But even more than that, in fact, let's not say weeks equals risk, let's just say time in general is money flowing into something without a result is an elevation of risk. And then the manual processes themselves simply open up holes for potential misconfiguration, things that are very difficult for us to isolate or overcome, because we're not exactly sure when and who and what and those types of things took place in order to open some form of breachable gaffe, if you will, in our deployment processes and our change management processes. Now we have a ton of audit and things like that's in this process, but every time we add additional audit, we increase the time and risk associated with the release. And so we're trying to find kind of a better approach to dealing with attack surface. But a lot of what we're asking is, but what if, right? What if we took a different approach to dealing with these through, think of it as centralized control planes or workflows that would allow us to actually control all of this centrally. One thing that we can start with is, let's start with kind of that server environment. If I was going to stamp out a number of servers and begin to manage them as a fleet of resources for the applications that we're going to run in the cloud, it could be any cloud. It doesn't have to be the private data center. It could be the private data center, but it could also be any cloud. And what if I could just define our best practice implementation of these various servers and define them as code declaratively? And I'm sure a lot of you have heard of this kind of concept of infrastructure as code, but we're really going to talk about everything as code, networking, etc. So if we're going to talk about things being delivered as code, that gives me a good, clean audit plane to start understanding the intent behind the deployment of these servers. And that's the first thing that I can actually use to sort of provide audit, right? So if I have my GRC, right, my global compliance team, governance, risk, those teams are going to be taking a look at this code and the approaches that we're taking and ensuring that we're meeting policy expectations because it has been defined, it's been written down, it's been codified. Now, what if we could even take all of that collaboration with the security and compliance teams and actually automate the deployment of those applications to ensure that everything met all of the compliance standards that we have within the organization? Then, what if we could, as we build out this infrastructure, include a standard best practice for deployment of application workloads that is codified, that intent is well defined? What about registering services, establishing network connectivity in a very low trust environment? What if I could include that in the environment as well for kind of self-service consumption? And then also, what if I dealt with secrets more transparently than before, much more dynamically than before, and actually sort of inject them into applications as they are demanded and as a service sort of approach? What if I could provide all of this and then control them via external control planes, where I'm actually managing things like the intent of what I'm trying to accomplish, as opposed to actual like individual IP addresses. IP1 can talk to IP2, it can use TCP allow, as an example. Those rules are very hard for me to extrapolate why that rule exists, but if I can do the inverse and use intent to drive the automation, I have a much better sense of how I am using these resources. So let's start with the infrastructure side with Terraform. And the immutability of infrastructure is actually something that gives us a much better approach to dealing with our attack surface, because I'm not patching systems in place. I'm not dealing with all those frameworks. I'm simply replacing them which removes things like unwanted writers, right? So any kind of malicious code is going to get wiped out. I've already talked quite a bit about audit, but Terraform also gets us into a place where we're working between teams and we're providing access controls to who can work with what pieces of infrastructure, when, where, and how. This again goes back, this supports that audit function. It makes sure that I know this is the networking team who provisions the networking assets that are going to be running in our cloud. I know how to track responsibility when I'm dealing with Terraform in a centralized fashion. And of course, I mentioned the intent of things like the policy. I can see that when it rejects a production role of infrastructure, I get immediate feedback as to why that happened, and I can understand the intent of the policy, and I can either adjust or go through kind of manual exception processes, things like that. Let's get into kind of the core or heartbeat of what we're doing from a security standpoint, and that's really with Vault. And again, I'm going to start, and I probably should start all of these bullets with intent, but the idea is I want to establish intent between multiple entities within our IT group, right, within our systems. Whether it's a human, whether it's an application, what I would like those things to be able to do is assert a really strongly understood identity. And then if they're requesting access to something like a database, Vault will understand, is there an intent? Is there a rule that allows this person or this application to access that resource? If so, let me go ahead and create the credential potentially, or issue an existing token for a static credential that you can then use. And the idea then is that I don't have that chattiness problem with the application because I'm pushing a token around. I never see the password. But this indirection actually gives us a lot of control over how we manage the life cycle of all sorts of credentials. And these could also be, certificates for things that are running around in, kind of that service-to-service communication, managing mutual TLS as an example. But any secret that we're talking about, and the core heartbeat of that is going to be, can I attest to that ID? And so Vault is going to provide a centralized place to manage all IDs as they sprawl across all the various clouds, and then assert aliases against those various clouds. And then when a system makes a call to me, I can actually introspect the underlying system to determine, is this who they say they are? Can I attest to their identity? And then because this indirection is in place, I can get very, very dynamic. Everybody can have their own secret. I'm not dealing with group secrets. I'm rotating secrets dynamically very, very quickly, maybe for an individual transaction. And then finally, I'm able to also do things like encryption. Pass Vault a social security number, a credit card number, something like that, and get ciphertext back so that I'm not actually storing anything that's in the clear. Everything that I see is encrypted, and I have to attest. I have to have a strongly attested ID in order to unlock any of the secrets that are being managed. Now, if we turn to networking, we've already kind of discussed how it's very difficult for us to talk about security holistically without dealing with the perimeter. Perimeter has been one of those stopgaps to help us establish trust within the network. And Console is taking a look at how can I deal with services from an intention point of view. Rather than those kind of fine-grained firewall rules where it's an IP to an IP, I need to try to establish trust between systems using an intention-based approach. Again, using that web application can talk to the database as an example, would be an intention that Console would enforce. So if you think about something like the Target breach as an example, where the HVAC system called into a store and then rode that network back to corporate, there should be intentions in place that actually prevent those hops. Another thing that I want to do with networking is I want to push our routing and authorization to the edge. So I want to make local decisions as to where is the service that I'm reaching out to, and do I have authorization to talk to it? Do I need a credential? In order to do that, I need to be able to dynamically discover services. So when a service is actually deployed to this environment where Console lives, I get a dynamic registration event. I know it's there. I know whether it's healthy or not healthy, and I can handle routing traffic that way. And then it's a simple half step to go from that to a zero trust networking situation where the services themselves have local information to understand, do I have rights to connect? What policies should be enforced against that? Do I need a certificate? Is it mutual TLS? All of that can be pushed out to the edge, so the decision making is not going bottlenecking through a load balancer firewall kind of thing. Now I know we need to wrap up pretty quickly, so I'm just going to keep writing ahead here, but as we start talking about things like scheduling application workloads to run, I need it also to be defined in an intent-based fashion. You know, I want this to be a blue-green deploy, this number of instances with this scaling policy. I'd like to have that competency reach across all workloads, containerized, non-containerized, on a platform, managed, unmanaged, etc. I'd like to establish best practices around change management for the application development teams, as well as provide facilities for operators to deal with kind of the fleet aspect. Can I pull 10 servers out, update them, put them back in, and still keep the developers very happy with what they're seeing? So again, that's audit. That's a good way to keep us clean on what we're trying to accomplish with the application rollouts, etc. And so this brings us to kind of some takeaways. I know I didn't provide a lot of examples, but we can certainly go into that afterwards. But the takeaways are obviously intent. Try to find a way to manage things via intent. It's going to be much more intuitive to understand, and obviously auditors are going to find that easier and more palatable to consume. ID is going to be key here. How do I attest that this particular instance is who they say they are so that I can grant access to things? I'm trying to mitigate blast radius through these intent-based policies as well, so I can see who did what, when, how. I can actually cut them off at the pass, because yes, you may have gotten access to one service, but you can't fool the second service in the chain. And then I'm also looking to automate everything that I can automate to remove manual mistakes that lead to breaches. You know, a misconfigured WAF for Cap 1 was something that led to an $80 million kind of problem. And so finally, the last thing that I'll say is you can also really look to unlock innovation by providing that psychological safety that will allow developers to move with confidence without looking over their shoulder that they're about to break something really, really badly. So thank you very much for the time. That's really it for the content, and I'll be around to answer any questions, I believe. So thank you very much.